As a DevOps engineer, you end up repeating the same checks again and again. Is the pod running? Is the disk almost full? Are there errors in the logs? Doing this manually once is fine, but doing this every single day is not. And this is where shell scripting becomes more powerful. And this is not a deep dive into Bash. We are not going to learn complex syntax or advanced scripting tricks. Instead, we will focus on things DevOps engineers actually use, like variables, loops, conditional, and small real-world scripts. The goal is simple: turn manual commands into a repeatable automation.
Before automation, we must understand how a script is created and executed. A shell script is just a text file. So let's create a one. So to create a shell script, we can use any of the file editor like Nano and the VI. For now, I'm using a VI editor here. So to create any file, we can use VI and the file name, that is file.sh. So the first line we usually add in a shell script is called a shebang. So let's add a shebang here. For that, we can use hash and the exclamatory sign followed by a path of a bash shell. So that is bin/bash. So it tells Linux which shell should run this script, and /binbash is the path to the bash shell. So this line basically means execute this script using a bash. And most shell scripts include this line to make sure the script always runs with the correct shell. Now let's save the file and exit the editor. For that, we can press escape and the colon and WQ. That means save and exit. As we can see, the file.sh got created. By default, Linux does not allow scripts to run as a program. So we need to add execute permission in this. So for that, we can use a chmod command. That is chmod plus X. That means execute permission to this file. And the permission got added successfully. Now let's run ls here. As we can see, the color got changed to the green. That means this file is an executable file. And this uses the same permission concepts we discussed earlier. Now we can run the script. For that, we can use // and the file name. So the // means run the script from the current directory. Linux does not automatically run files from the current directory. So we explicitly specify the path here. Now let's press enter. It doesn't print anything as of now because we just added a shebang to tell the script that this script is a bash script. Now that we know how to create and execute a script, let's see what actually goes inside one. So for that, we can start with the variables. So variables allows us to store values so we don't repeat the same information everywhere. So let's modify the shell script and add some variables into that. So for that, we can use the VA file.sh. So let's create a variable here. So I'm going to give a variable name that is app_name equal to nginx. So I gave a name to the variable that is app_name and its value is nginx. And in shell script, there must be no spaces around the equal signs. Now, if we want to use this variable, we can prefix it with a $sign. So now let's use this variable. So I'm going to use a echo and the $sign and the variable name that is app_name. So $app_name tells the shell to print a value stored inside the variable. And in real DevOps scripts, variables are often used to configure things like application names, paths, or even environments. So let's save and exit. So let's execute the shell script. So file.sh. Now we can see the variable value that is nginx, which we have stored inside the app_name variable. So variable stores information, but automation also needs decision. That's where if condition comes in. And if condition lets a script decide what to do based on a result. So let's edit the same file. So vi file.sh. So first of all, let me comment out these two lines. So to comment out any of the line in the shell script, we can use a hash sign here. So hash. So this line is commented and shell script will not execute this line. And for this one as well. So now to demonstrate if condition, I will start by creating a simple variable called status. So status equal to running. In real DevOps script, this value usually comes from a command, like checking the status of a pod or a service. But for now, we are just setting it up manually. So now let's write a condition that checks this value. So to write a if condition, we need to use a keyword called if here. If, and then the square bracket open and the square bracket close. So this square bracket is used in shell scripting to evaluate a condition. So I'm going to put a condition inside these square brackets only. So I'm going to use a variable that is status. So $status equal to running. So here I am using the variable which I have created, that is the status, and I am going to use its value. That's why I use a $ symbol here. And then I'm going to compare the value of this particular variable to a string that is a running, and the value we expect is running, which is already stored inside the variable as well. So here if you notice, while creating a variable I am not giving any space, but while comparing the values I am giving a space between the variable and the string, and after that we need to give a semicolon and the then keyword. So then tells the script what to execute if the if condition is true. Now I am going to add a string here, that is echo application is healthy. So if the if condition is true, this command runs. It simply prints the application is healthy. But what if the status is not running? So for that we can use a else keyword here. So else, and then I'm going to use echo here and with the same line, but application is not healthy. Is not healthy. So in the else condition I'm just putting if the status is not running, then print this line that the application is not healthy. That's where the else blocks comes in. It handles the situation when the condition is false. And at last, to close a if condition, we need to use a keyword called fi. In the shell scripting, the block often close with a keyword written backwards. So I started with the if and the backward is fi. So now let's execute this file. Let's save and exit. And let's run this file, that is file.sh, and we can see the message got printed, that is application is healthy because the variable is running. Now let's edit this file and let's put some another value in this instead of running, that is not running, and let's save and exit and let's execute the file again, and we can see the message got changed because in the else condition we put application is not healthy when the status is not equal to running. So now we have understand the if condition. So if condition allows script to react to a system state automatically, and this idea is used everywhere in DevOps automation, checking pod health, disk space, service status, and much more. Sometimes we don't check something once. We check it multiple times, and that's where loop become useful. In DevOps, we often repeat the same checks again and again, retrying a failed deployment, running healthy checks multiple times. Instead of writing a same command repetitively, we use loops. So let me create a new file here, that is vi loop.sh, and let's add a shebang first and bin/bash. Now let's create a for loop here. So for that we can use a keyword called for that tells the shell script to start a for loop, and then I am going to use a variable that is I, that is a loop variable, and then I am going to use a keyword called that is in, and in defines the list of values we want to iterate through. In this I am going to use numbers here, 1 space 2 and 3. So now we need to define what loop should actually do. So for that we need to use a do keyword here. So do marks the beginning of the loop body, the command that will run during each iteration. And for that I am going to use a command that is echo and then printing check number, and I'm going to use a loop variable here, that is I. So if you notice, I use a I here, that is a loop variable. So $i represents the current value of the loop variable. So every time the loop runs, the value of the I changes. And to end this loop, we need to use a keyword called done. So done marks the end of the loop. So now let's save and exit this script. So the script got created. Let's make it executable. So chmod +x and the loop.sh. Let me clear out the screen. Now let's execute the script, that is loop.sh. So if you see the output, each time the number got changed because in the for loop we give 1, 2 and 3, and the same has been printed here using the loop variable, that is check number 1, check number 2 and the check number 3. Now that we have understand variables, conditions and loops, let's apply these concepts to some real DevOps script. So instead of writing everything from scratch, I have already created a few scripts and placed them inside the script folder to keep things organized. So if I do ls here, we can see the folder that is scripts. So let's go inside this. Let me clear out the screen. And so here I have created 3 scripts, and each script solves a common DevOps problem, and we will go through them one by one and understand how they work. So let's start with the first one, checking the Kubernetes pod health. For that I have created a script that is checkpod.sh. So let me open this file. So the goal of this script is simple. it checks whether Kubernetes pod is running or not, and this type of check is very common in automation, monitoring and the CI/CD pipelines as well. So let me enable the line number here, and to do that we can use colon and the keyword that is set and the NU. Now we can see the line number against each line in the shell script. First of all, we use a shebang here to tell Linux to execute this script using the bash shell. And after that, in line number 3, I have created a variable pod underscore name. And in specifying the value of it, I use a different expression here, that is dollar and the curly braces. And this is a parameter expansion. And here I am giving a variable name that is a pod name. After that, I have used the colon and the hyphen symbol that specifies the default value, that is nginx. So that means if the variable pod name is already exists, the script will use it. Otherwise, it uses a default value that is nginx, which I have specified using a colon and hyphen. So this avoids hard coding values and making the script reusable. So in any case, the pod name is not there, so then it will use the nginx as a value for the pod underscore name. After that, I am creating another variable that is status. And for that, I am using a dollar and the round brackets, which is called a command substitution. So it runs the command and stores the result inside a variable that is status. And if you see inside that, I am running a command that is kubectl get pod and the pod name variable which I created earlier, and inside that I am just specifying the status of that particular pod using the JSON path. So this status could be like running, pending and the failed. So whatever the status of the pod when we execute this shell script, it will be stored inside the variable that is status. And below that I have specified the if condition. So this line looks similar to our previous shell script because I have used the status as a variable over there as well. But this time we are getting a dynamic value while running a kubectl command. Earlier we use a variable. So this condition checks whether the pod status is equal to running or not, and then it prints the pod name and prints that is healthy and exit the particular script with the status code 0. And if it is not healthy, then it will print the pod name and mention that pod is not healthy and exit with the exit code 1. So the exit 0 means success and exit 1 indicates a failure. So in DevOps, script don't just print messages, they signal success or failure using these exit codes. Because when we are working with CI/CD pipelines, monitoring tools and even Kubernetes jobs, all rely on the exit codes to understand whether something succeeded or failed. So now let's execute this script. So let's save and exit. And let's execute check pod.sh, and we can see the pod nginx is healthy because it's already running on this system. So kubectl get pod, we can see the nginx pod is running. So checking pod health is very common, but another important operational check is disk usage. So let's look at the second script that is for checking the disk usage. For that I have already created a script. Let me open this and let me enable the line number here as well. So at first we use the shebang as well. So it tells Linux to run this script using the bash shell, and after that we define a variable called threshold, and for its value we use the parameter expansion and the default value as well, that is 80. So that means if the variable threshold already exists, the script will use that value. Otherwise it uses a default to the 80%. And below that we also define another variable that is usage, and here we are calculating the current disk usage of the root file system. So first of all we use the df command. So df stands for the disk free, and it shows the disk usage of the file system, and here we are looking for the root file system. And then I have used a tail -1. So it extracts the last line which contains the actual disk information. And after that I have used the awk command, and awk prints the 5th column which is the disk usage percentage. Till here we are getting the disk usage percentage, and at last using the set command we are removing the percentage sign as well. So now the variable usage contains a number like 63 and 50. After that we are defining the if condition. And if condition, we are comparing the current disk usage with a threshold limit, and -gt means greater than. So if the disk usage is greater than threshold, the script will trigger an alert. So inside this condition, we are printing disk usage high and the actual usage value of it as well. And after that, we are exiting with the exit code 1 that indicates failure or an alert condition. So the monitoring system can detect this exit code and triggers an alert on the basis of this exit code only. And if there is a normal disk usage, so it will print the disk usage is okay and print the actual utilization of the disk and exits the script with the 0 code. That indicates success, means everything is healthy. And at last we are closing the if condition block. Now that we have understood the script, let's trigger it and let's see how it works. So let me save and exit.
So let's run the script. So check disk usage. So right now we can see the disk usage is okay because the disk utilization is very low, that is 10% only. And if I run df/command, and we can see the utilization is only 10%, and the same value we got here as well. And now if we want to see the exit code as well, so we can use the echo dollar and the question mark. So it gives the exit code of the last running command. So right now it's a df/ and it executed successfully. So it prints the same thing. So let me run the same script again. And if I run echo dollar question mark, so the exit code is 0 because we have said if the usage is below than threshold, it exit with the exit code 0. Now let's change the threshold limit to some lower value than 10 and let's see how it works. So if I open this file again and let me update the default value to 8 and let's run the same command again. So check disk usage. As we can see, the disk usage is high, that is 10%, because we have set the threshold limit to 8 only. And now if I run echo and the question mark, we can see the exit code is 1, which we have set in the script, because if the disk utilization is higher than the threshold, it exits with the exit code 1. And the same thing can be detected by the monitoring system and raise an alert. So this small script automatically checks disk usage and signals whether the system is healthy or approaching a storage problem.
Now let's check our last script that checks the log file, and that is log.sh. So this script monitors the log file in a real time and detects error automatically. And logs are often the first place where the problem appears in the production system. And so instead of manually opening a log file and searching for errors, we can automate that process with a script like this. So let's walk through it step by step. So as usual, I use the shebang here, and then I have created a variable that is log_file, and here I have specified the variable that is log_file and the default value that is var log messages. And here I have used a tail-f and the variable that is log_file, which has a file value. So tail-f continuously follows the log file. As new lines are added to the log, they appear immediately in the terminal. So instead of checking logs manually, the script listens to the log in the real time. And then I have used the while read line here. That means the output from the tail-f is passed into a while loop, and this loop reads the log line by line. So every new log entry is stored in a variable called line here, and after that I am starting a while loop using a do keyword, the same thing which we have used with the for loop as well. And inside that I am specifying the if condition. Here I am using a echo and the dollar line, because we are storing each line of the log file inside a line variable, and inside that particular line I am grabbing for the error keyword, and if the error is detected, it will print that error detected with that particular line and ends the if condition and also ends the while loop. So this script continues watching the log file and check every new line for errors. So let me save and exit. So let's execute this script. So log.sh, and if you notice, it printed error detected and the line. So first of all, it sees the file that is var log messages, and inside that we got an error, that is this one. And after that it went into the condition and prints that error detected with the error message, that is this one. And this script makes it very easy to immediately see which error have occurred. And using this, we can troubleshoot the error and resolve it timely. And whenever an error appears in the log file, the script immediately prints it. So scripts like this are useful for real-time monitoring, like application error detection, security alerts, debugging production issues. So instead of scanning logs manually, the script automatically highlights the problem. And this is a real example of an event-driven automation reacting to event as they happen.
Instead of constantly checking logs manually, the script reacts the moment something happens. Now notice something important here. None of these scripts are complex, but each one removes a small piece of repetitive work, like validating services, checking disk usage, and monitoring logs. And this is what DevOps automation actually looks like. Small scripts that save time and remove manual effort. In the final video of this playlist, we will bring everything together we learned so far, like networking, storage, namespaces, and automation. So you can see how these pieces can fit together in a DevOps workflow. And before we end up, remember one important thing. DevOps is not about knowing command, it's about knowing when to automate them. If you found this helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.